more time and effort to sketch these than it is to just apply them as a applied chamfer.
Yeah, that's really a great point too. It's kind of, Mark, you and I have done a bunch of training, and that's like one of those first steps that you get to is taking a look at a piece of geometry and breaking it down into what features am I going to use where, right? That mental step is always really valuable, extra valuable when you're taking an exam, right? Because you're under the time crunch, right? And Matt Clegg was just saying in the chat a bit ago that time management is usually one of the things that gets people. It's not so much that you don't know the skills, it's just can you get them all implemented in the amount of time that you have. So taking the time to do this is often something that people will skip. They just dive right in and say, "Oh shoot, I'm under the time crunch. I'm just going to go as fast as I can." But to take the time and think this through will almost always save you a bunch of time in the long run, because you've thought through the process of what you're going to do and where you're going to apply things.
Exactly. And something else that's going to help out with that time is some of the other tips I was suggesting earlier about things like keyboard shortcuts and that sort of thing. And just being efficient about your mouse movements. So I want to start sketching, for example, on the front plane. So I could go to sketch and then select the front plane, over here. But to me, it's easier if I just select the front plane and use this context sensitive pop-up window.
And Mark, speaking of shortcuts, you taught me the Q key a while ago, which I've been using nonstop. So good tip for showing and hiding your planes quickly.
That's a great tip. Yeah, exactly. So yeah, if you just use Q, that just brings up all your planes. So then you can just select here, sketch right there. That's a great tip. There you go. So you'll see that the screen rotated. We're now normal to that plane, and we're ready to get started. So with this sketch, I'm just going to start at this bottom left-hand corner and just kind of go around trying to create these bits of geometry. I'll start simple and then just kind of get more complex as we go. But I just want to try to get something on the page close to, but not exactly what's shown. So I just want the general shape. So I'll start on the origin. I always like to start there just to get that coincident relationship. And you'll notice with my cursor that, sometimes you're getting like these little yellow boxes next to the pencil. That's just telling you that it's going to create a relation automatically. So if I click now, it's going to create a vertical line for me. So these are really helpful shortcuts whenever you need to create vertical or horizontal lines. If I come out here straight to the right, I'm going to get a horizontal line there. If I want to angle a line down, that's great. I can do that. Now I need a curved section here. A really great shortcut for this is just to move your cursor back to this endpoint of this line and come out. And now you have this little curved line there, just like that. If you want to get back to a straight line, you can hit the A key. That will get you back to a curved line or a straight line. You can actually use the A key to alternate again to that curved line. So just a couple little tips there. Click there. We're going to come out to the right a little bit horizontally, down vertically a little bit. Another angled line here, another horizontal line here. This one, I can't do that little trick because it's not tangency here. So I'm just going to do, let's just say a basic straight line. I can do tangency here. So I'm going to come back, get a little curved line there. And then I'm just going to finish that up by clicking at the origin. Okay, so now I've created a closed profile. We can see that. It looks something similar to this, but there is certainly some cleanup that I have to do. I think I did a good job with those inferenced relations. But there's still some things I wasn't able to do quite well. And so I want to start by making sure I have all my relations first. Then I'm going to do all my dimensions. And my goal is to fully define this sketch using the information shown on the screen. So if I select, for example, this line here, I want that to be horizontal. So I'll use the context sensitive pop-up window here and specify that I want that horizontal, for example. I want this and this to be tangent. And so I can actually select the point in between the line and the arc and say make tangent. The other way you would do that is you would select the line control on your keyboard, then select this arc, then you can make that tangent that way. This is the line that really wasn't supposed to be there. So I'm just going to get rid of that using delete. And now what I want to do is use a 3-point arc to create this arced segment here. But instead of going all the way up to my sketch toolbar and selecting 3-point arc here, I'm just going to use the S key on my keyboard. And that brings up my commands that I can quickly access here. Now, these are the default commands that are on there. And you can do 3-point arc straight from here, but you can also search any commands or tools right there if you want. So here's my 3-point arc. So I'm just going to select one point, the other point, and then just some sort of midpoint there. Okay, hit escape to get out of that. And we're looking pretty good. Now, this is just a general layout of what this should look like. I need to apply dimensions in order to fully define this. And fully defining is very important. If your sketch isn't fully defined, it's likely that you will probably get the question wrong. So all the information you need is going to be here. So just make sure you use all that information and use it in the way that you're doing here. With dimensioning, I usually like to start with the larger dimensions first and move to smaller ones. So the largest dimension here is going to be A, then B. So I need to know what A and B are. So there's A and B, 81 and 57. So time to use the Smart Dimension tool to start defining my sketch. So I could, again, go all the way up to my Command Manager toolbar and use Smart Dimension here, or I could use the S key. There's Smart Dimension on that one. Or if you want to, you can play around with the
we just got a comment from mouse gestures right in the chat there. Yeah,
mouse gesture wheel. Yeah, I forgot what it was called for a second. So if you click and hold your right mouse button and kind of wiggle it around, you have by default these 4 quadrants that you can just swipe through. So if I swipe through this top quadrant, my cursor is now a Smart Dimension tool. If I do that again, it turns it off. So that's a very fast way of getting to that Smart Dimension tool if you want to try to use that. That can be configured to 8 or I think even 16, which is probably a bit overboard, but 8 is probably a good sweet spot. So we need to dimension these. So for dimension A, I'm going to select these 2 lines, drop this down, and click here. Now, there's a reason why I put the dimension down here, and it's often overlooked, but it's something that you will do over time as you complete these exams because you recognize how powerful and useful this is. What I'm doing here is I'm just trying my best to make sure that my screen looks as close as possible to what's been given to me. And so what I'm going to do is try to place these dimensions in the same exact place. That way, if I don't feel confident about my answer, I can always look back and just double check and just go left and right. Kind of, what was it? You were in the doctor's office and they had like the little book where you had to like see what was wrong on one side. What was on one side wasn't what was on the other. Something
one of these things is not like the other kind of a thing.
Yeah.
So as we just saw, passing certifications, that whole topic, it has its own tips and tricks associated with it. You know, how do you manage your time? How do you effectively practice? However, another area of SOLIDWORKS that certainly has its own tips and tricks associated with it is working with imported geometry directly inside of SOLIDWORKS. So recently, Barry Setzer of Titans of CNC shared the live design stage with Brian Zayas in showing some of his favorite tried and true moments of editing aerospace geometry inside SOLIDWORKS 3D CAD. Whether or not you've worked in aerospace or worked with imported geometry even before, I'm totally confident that you'll learn something new and valuable from this next clip featuring 2 absolute SOLIDWORKS whizzes. Let's take a look.
Dumb solids, right? Just what kind of direct editing tools we can use to take whatever format we're getting. You know, someone sends us a step file, someone sends us a share and markup, you know, and downloads the step file. What can we do? And I know there's so much modification that happens between the design, model, and fabrication. And that's a whole other topic. I got tons of questions that I want to understand about how we can close that loop with mutual understanding. But I guess that's what you're all going to get out of today's episode is a really good triangulation of SOLIDWORKS tips from an expert with a lot of good perspective from manufacturing, which I guess really informs then what your CAD should look like, right? In terms of precision, quality, and robustness. So enough yabbering. Barry, do you want to bring up the model you were just showing me? That would be a great place to start.
Sure.
Oh, this is great, man. And he by the way, big thanks to Barry for downsizing his jumbo wide 4K and his beautiful workspace there down at Titans. But so this is an aerospace component, and maybe I'll let you share a little bit more of the background and maybe what's the girth of this thing. It looks very slender and difficult.
Yeah, so it's roughly 12 feet long and maybe 8 inches wide here at the widest point.
12 foot 8 inch. Yep.
Yeah, this was probably the most difficult part I ever had to model in my career. Took me several months to finish it, and it may not look like much from here, but once you understand a little bit about aircraft drawings. All of these surfaces are lofted. They're all tapered. Nothing's flat. It's got all these different tilted walls and fillets everywhere, and it was just a nightmare. And it was a hand-drawn drawing that was just...
Well, let me say to everyone out there, like Barry showed me under the hood already, there is a whole surface modeling master class in terms of legacy drawing, what TIFF files or whatever, scanning them. I mean, you said you hunted out 20 drawings. You're creating line art, surface extrudes off sketch pictures. I feel like that's a whole nother topic. But I don't know if we have time. If you guys want to see that, let us know in the chat. Do you want us to get back into drawings, modeling this from legacy? Because I also loved where you were starting here, which is hot mess. I mean, there's not even a material on this thing. It's a dumb solid, if I can say that, because I don't know, is a step file like this? Yeah. But this is typical of what you get and what I'm sure we all end up starting with, right? A dumb solid, one way or another.
You look at the part like this, and you can't, feature recognition is great, but on something like this, you just can't do it because there's so much going on. I mean, so many lofted surfaces, so many crazy fillets. I mean, I showed you the actual tree yesterday where I think it had, I was on like fillet number 270.
I thought it was 400. I mean, it was, guys, again, it's a master class.
It was brutal, but when you get a part like this in machining, a lot of times, you'll get a model and say that this is a Rev F model, but then there'll be like, 7 EOs after it that are changing things, but this Rev F model doesn't have that. So as the machinist, I have to look at those EOs and I have to modify the features that are required for the finished part because it won't match this model.
Oh man, so you end up having to put all the input together and basically be the final CAD designer.
Yep.
And again, this is something I want to come back to. If we have time, is like, then how do we get that back in engineering hands, right? Like there's so much modification that happens during fabrication, installation. Like,
yeah, and it's funny, a lot of the times you'll model a part like this for, a third party, and you'll ask them like, hey, do you want me to send you the model so you could share it with your customer? And they're like, no, we'll never use it.
Oh, yeah.
It's like, okay. Some of the things that'll make you faster, things like understanding what certain errors mean and what's causing them, how to fix them, and how to take some shortcuts that, even if a shortcut only saves you, say, 5 seconds a day, over 20 years, that adds up. So, sometimes it's the little things, and sometimes it's basic things. We talked a little bit yesterday about how there were times where I was doing things like the dumbest way imaginable for years until I saw somebody do something, and I was like, wait, how did you just do that? So, there's going to be things in our live today that will appeal more to beginners. Some of it will appeal more to experts, but I kind of wanted to cover a full gamut so that we had something for everybody. Since you brought it up, we'll start with something super simple. If you look at all of the tabs that we have in SolidWorks, there's a lot of stuff in there, but what sometimes you might not realize is there's even more that's not shown up here. So, for me, I know the tools that I use on a
Barry's awesome
basis.
Tab.
Yeah, so like I've created Barry's awesome.
Okay, no, pause here. I mean, this is the one. Oh yeah, delete body, delete key, body, delete face. Yeah.
Yep. And I really like the SolidWorks user interface for these tabs and toolbars. Like if I wanted to throw something else on there, I just go to Tools, Customize, if I could get down there, and then just go to Commands.
Yeah. Mm-hmm.
And I love the fact that you can search for a command. So if you already know what the command is, you can just type it in there and find it. Like if I'm looking for measure, say, I want to put measure on.
Oh man. Well, you know what you can do now? Are you in 2023, by the way, or what version? S key command search, by the way. You bring up the shortcut bar and the command search is right there. 2023.
Yep. But if you're not using 2023, you can just find the command you want and just drag it up to your toolbar. Done deal. Let's just say that they come and tell you that they want a additional rib, and let's just say they want to go 3 inches off of this face and put another rib here that goes from this wall to the wall next to it.
Okay.
Now, whoops. Come here, mouse.
I imagine that's got to be tapered or drafted, yes. I guess. Is that the right way to say that?
Yep, they're drafted and they're also tapered outward. So you can't just draw a rectangle on the floor and boss that up. There's a lot of things that you can kind of do to cheat it. But in this case, I wanted to show two methods that I use when I have to do something like this, especially on contoured parts or, parts where I don't have edges that I can convert. So the first way we're going to do is we're going to go ahead and put a plane in.
Okay.
3 inches off of that face.
Is that going to be the mid plane?
No, I'm going to use this as one of the outside planes.
All right.
We're going to create a loft here. But to get the geometry of these walls and floors, to get actual edges that I can use here, the first tool I'm going to use is split line. So we're going to use this plane.
Oh, interesting.
And then we're going to select the faces that we want to.
Oh, dude, I haven't used this in years. I mean, with simulation, this was like a godsend to get this because you could, split where you want to apply a force. So
yeah.
Show that one more time.
Sure.
That is one of those tools we were just talking about. If you are just learning that now, again, tell me that years ago when I started. So
and split line I think is part of the mold tools. Toolbox, but again, I have it out here on my Barry's Awesome tab. So all you got to do is click. We created our plane. We're going to pick split line, intersection, and all of these things are useful. You just got to play with it to know what each one.
So you're not making a sketch or trying to do some 3D sketch or multiple planar sketches and convert entities. It just slices all those faces with this plane.
Yep.
And you could probably do surface bodies if you want to do some kind of curvilinear intersect.
Yeah, we could. And I kind of just wanted to show.
That's great.
This so that we can see how we can get those edges at the exact plane where we need them. And now that we have those edges, we can do just a plain sketch on that same plane. We can convert those edges.
Now you can do that.
Whoops, not that face.
Yep. That's brilliant.
Yep, and then we just draw our line across the top. Boom. Now, that's one section of our loft. For the second one, we're going to do it a little bit different way, but I like this way because I've used it for a whole lot of different things, and a couple of the other guys here have also found it useful. So now we're going to create another plane, 1/8 of an inch off of that one. And now, rather than using split line, and sometimes you may not want to use split line because you want this to be a continuous surface when we get into machining for our CAM software. So what we're going to do this time is we're going to select that new plane and we're going to do cut with surface, and we're going to cut our part off that plane. Now we still want the stuff that we cut away, but now we want these edges here. So what we're going to do is on that plane that we used to cut, we're going to sketch. We're going to do just like we did with split line. Draw our little top line here.
Dude, you are stealing edges. This is great.
Yep. And I like to call this a ghost sketch.
A ghost sketch. Okay, I was going to say, what do you call this? This is.
Yeah. So right now, if I were to close out of this sketch and delete that surface cut, my sketch will have rebuild errors in it because it's tied to these edges that are no longer going to exist. And that's something that, going from like CATIA to SOLIDWORKS, SOLIDWORKS' tree is chronological, and I love that about it because, what you did here, can't exist until what you did before. Oh, my mouse is going crazy.
Zoom to fit. Yeah, there you go. No, so in CATIA, what would be different about that? The references, the edge references.
Yeah, I mean, back when I was using it, I'm not sure what it's like today, but it had like a separate tree for curves and separate tree for surfaces, and it was just really different to me because I'd used SOLIDWORKS for years before I got into CATIA, and my bread and butter has always been SOLIDWORKS. I've always been a little bit better with it, but with this sketch here, so that we don't end up getting that rebuild error, we're going to just right click off in space and say display delete relations.
Sure.
We're going to delete all of our relations.
Yeah. Okay.
And then we're going to pick our whole sketch and fix it.
Sure. It's like a in context assembly, part modeling, no references made.
That's right. And that's why you got to be careful when you do this, not to sketch on this face, but to sketch on the plane. Because if you sketch on this face, that face is going to go away here in just a second, and then you're going to have another rebuild error for not being able to find the sketch.
Oh, this is great. So just to recap the last couple minutes, what Barry showed us is what he's calling a ghost sketch, which is the next station for his loft. The first one, the plane one, he was showing us using intersect or split to create an intersection. That's great. But here he doesn't want to create any sharp edges, right? Just have those sketch entities. So, a lot of, I think, under the hood SolidWorks model tinkering probably comes down to techniques like this. This can be very handy to get the edges you need to then create one more station, or is this it for your loft? Do you need to create another one?
This will be it for this one.
All right, let's see the next step here. I know everyone's eager to see, where do you go from here?
So once we get out of there, we now have this sketch using those edges that we just created with that surface cut. But now if we delete that surface cut, our sketch is still there.
Nice.
Not dirty. And now we have our whole part back.
Yep.
So
that's
the next
great.
thing I wanted to show, a lot of getting good and fast in SolidWorks is when you get errors that you understand what they mean and why you're getting them. So right here, if I wanted to create this new rib, I could just loft it.
Kind of clicking it in the same spot. So those
and I talked about that a little bit.
The last one, I was gonna say the tangents or the connection lines. Yep.
Yep. And we'll show that again real quick. Back when I first started lofting, I had no clue what was happening. I would just do like that, and it's like, that is not what I want at all. And then one day I accidentally drug this little control ball here, and it was like, so I just got to make sure that they line up with each other. And that can be kind of tough if you have two sketches that have a different number of sketch entities in them, but usually you'll be able to figure it out pretty easy.
Now look, sometimes in SolidWorks we design because we want to increase our standing in the workforce, right? Like with certification prep. And sometimes it's to get parts ready for documentation and machining, like we saw in Barry's episode just a moment ago. And sometimes we 3D model for completely different reasons, like, making your own action figures. So if you're unfamiliar with next-gen cloud 3D modelers we've created here at SolidWorks, like 3D Creator and 3D Sculptor, you will love what you're about to see from product experts Noah Zeef and Gian Calisi. Noah and Gian held a 2-part episode earlier this year showcasing the design and 3D printing of a set of custom action figures, which we gave away, by the way, at the latest 3D Experience World event in tandem with a super donation to our friends over at Magic Wheelchair. So let's take a look at some of the most watched portions of Gian and Noah's live design appearances.
So if I select that 3D shape that contains all of our OGSs, you'll see this is what's shown right now from our master model. This is the only part that's left shown. The arm itself that you still see there are the components that we just made. So those 5 components are what we just created. And now we can actually add some mates because they are their own components. So I'm just going to add a few here. I'm going to do a concentric between the upper arm and the shoulder, and then I'm also going to make that coincident, those 2 flat faces. And really that's all we need. We're just going to add a few more concentric and a few more coincident.
The same type of mates from SolidWorks?
Yep, okay. Same types of mates. And they pop up just when you just when you start selecting faces. And I'm going to fast forwarding through adding all those other mates. Let's actually test out the motion. Oh, I also changed the colors of the components so we can see them more easily. So
that is so cool.
Yeah,
that shows so nicely. And I remember this was especially useful when it came to manufacturing, because without having to spend any resources in printing, we already knew how much this was going to move, or we had a general idea of how much it was going to move.
Right.
So yeah, really useful there.
So we've got all that split into components. Our components are red, but our master model is still gray, just for keeping it easy to follow along here. We have mates for our arms. What I actually want to do before I finish this whole assembly off and make everything its own component, what I actually want to do is make changes to the master model. So we finished splitting it into components so that we can understand the motion and the efficacy of our assembly. Now we're going to change the master model, which We did a number of times.
We did a lot of revisions.
Yes.
Back.
A lot of changes. Most of it is due to our perfectionism, probably.
Right.
Yeah. So all self-imposed stress, but.
Right. Yeah. Once we started it, we had to go all the way.
Yeah.
There's once the head moved, the shoulder had to move.
Oh,
once that moved, his elbow had to move. So yeah, we definitely took it all the way.
But let's show what that actually looked like.
Yeah.
So changing the master model, jumping right back to where we just were. I'm going to hide these components, okay? And I'm going to show the arm again for my master model. So once again, we're all gray. We're just showing our master model now. And I want to make a change to it, to our original sub D body for that. So I'm going to go into that sub D for the arm. And yeah, this guy, he's been slacking on biceps a little bit. He's been doing too much shoulders. So we're making his deltoids a little bit bigger. And he's been skimping on the curls. So we're actually going to make his bicep a little bit smaller.
What'd you say? He eats iron for breakfast?
This guy
just tough guy.
He eats weights, but he's been slacking on the curls right now. So been too much shoulder lifts or whatever. So we made some changes to the sub D driving this. Our master model has now been updated. Okay. So now what I'm going to do is I'm going to hide this. I'm going to collapse that. I'm going to show our components overlaid on our master model, and see how they're kind of there's like gray, red overlapping areas.
Yeah.
So that's where the model is actually perfectly superimposed and perfectly overlapping, is where you see a lot of that interference or the overlap.
That's the master model and the physical products, right? That are superimposed on each other.
Overlapping with each other. But the 2 points that we just edited, the bicep and the shoulder, they don't have overlap. And the reason is because now our master model is bigger in the shoulder area, so it's actually popping through the physical product. Mm-hmm. And our bicep we made smaller, so now we only see the physical product left, the red part, and because the bicep in our master model has been made smaller and is now behind that surface. So I just wanted to show this so that you could see what is going to change, and watch carefully as I'm about to now just go down to solve this thing. So by solving this assembly, now you'll see we have perfect overlap once again.
Gotcha.
And now our components are now up to date with our master model.
And that's because you had external references turned on when you made those new components, right? So it would always look back to that master model.
Exactly. If we didn't have external references on, then it would have just been like a copy of the body or of the part at just that one point in time, and there would have been no link. So we would have been just kind of stuck with what we had. But now we have the master model that has all the geometry we actually work on, and that actually drives everything in our components.
Gotcha. I know you mentioned we're perfectionists. If you had to guess how many times we went back, or how many times you went back when you were sculpting this?
At least a dozen, or maybe a couple dozen times that we would go back, and whether it was a small change or a big change, I think did I mention already how we moved the whole knee up a little bit?
Yeah, we moved the knee up. We moved. I think we made his torso.
Yeah, his torso had to get smaller, and actually I think shorter. I think it was too long at first. Mm-hmm. And that's why probably would have helped to have some type of reference in here, but it was a challenge. I was trying to challenge myself here and see what we could do. But that's our components up to date now. We can hide that original part of our master model and just see our parts are up to date, our physical products, and we can replicate this process for all of the other components. So that the master model contains all the geometry. The assembly has all of our other parts in it that are driven by that, and by having it all mated up, we can test out the motion, like we were saying, for the assembly,
right?
And we can also test out some different poses for this guy.
Love that. So cool. All that's missing now is a simulation we could run on him, see how fast he can run, how much he could lift.
Yeah.
So let us know in the chat if you'd like to see any cool simulations with the X Design or X-Shape action figures. That'd be cool.
We would love to do that. But that was making the change to our master model. So quick changes there in our master model, drive changes in the assembly. So giving us that single point of, I want to say single point of truth, but that single point our master model being the only place that we have to go to actually make edits to the geometry.
Mm-hmm.
And then, anything with mates is all within the assembly. But that's just about it. So just to recap, we set up a master model.
Mm-hmm.
We used OGSs so that we could organize it and work on it efficiently. And then I showed how we sculpted some of the surfaces by just doing that whole arm from start to finish.
Mm-hmm.
We added some parametric details, punched a few holes through it, did a few revolves. Then we split it into individual components so we could understand the motion of that assembly. And then we finally made some changes to our master model, showed how those changes propagate into our assembly, and then we fast forwarded to the end where we had replicated all those steps and finally have like a complete master model and working assembly of this action figure.
Awesome. Looks so cool. And the product came out so great, I'd say.
And we did this not just for X Design too.
We did this for X Shape as well.
Yep.
Yeah, he's on the desk as well.
Yep.
And I almost think he was kind of a bit simpler too, because X Design, he had like those pockets, he had the knee pads.
Yep.
And his logo had different colors too, so we had to incorporate different parts. So I would say X Shape was in a way almost easier, right?
Yeah, X Shape was definitely easier, and not even just because of that, but we were also able to make X Shape. We just made a copy of the X Design guy. And I just made him a little bit less muscular, a little bit less.
Just took him out of the gym.
Yeah.
But his hair too, I thought that was really cool because, you could do a lot with subdivision.
Yeah.
But obviously sculpting like hair, like thin features, those would have been impossible to manufacture.
Yes.
So you had to really keep manufacturing in mind when you sculpted the hair of, say, X Shape, right?
Yeah, I did. And I mean, you saw the result. It's obviously it doesn't look like perfect hair. It's not like we just put a wig on the guy, but
it's action figure.
Exactly.
Worthy.
Exactly. It looks like plastic hair. I mean, he's got kind of a weird hairstyle. It looks like he just went through a wind tunnel or something.
Right.
Or he's just using way too much product.
But no, they look great. And let's see, we're actually at the top of the hour. So again, these are our two core apps: X Design with parametric, X Shape with subdivision modeling. And if you guys want these models, they're available to you right now for free. You go to solidworks.com/actionfigure-model, and there you could get the 3D XML, which has all these subdivisions that you sculpted.
Yep.
So you can mess around with those and have some fun. You can make them look like you hit the gym even more, make them even bigger. Or you could go to solidworks.com/actionfigure-STL, and you could actually download the STLs that are ready to go on a 3D printer. You can fire those up right away.
As kids, most of us, I think, played with action figures and trucks. Who didn't play with trucks? I bet most of you in the chat today probably did. But then some of us, we grew up to design functioning, high-performing, custom emergency vehicles, just like Sean, Luz, and the team over at PL Custom. So PL Custom took the live design stage earlier this year to review how they've used both SolidWorks 3D CAD and SolidWorks Electrical to design and configure custom emergency vehicles on both the mechanical and electrical fronts. Let's take a look at that episode.
The lighting will come up into controls into the rear switch panels back here. And then they also have a set of cab controls up here in the front. And that is where we are basically starting the electrical design. That's where we're starting to implement SolidWorks Electrical, is up here at the front of the cab in the console.
But let's take a look at what you have here on the electrical schematics or harnessing.
Well,
it looks like.
So this is kind of inside, from the console. This is a radio right here, and we have the switch panel with certain components. I, of course, didn't put everything because they are, but the main components are here. We have a 3 main harnesses, and for the entire ambulance, we use 5 main harnesses. They connect everything around this. So how many parts and lights Sean was showing in the entire truck. At this moment, I'm just concentrated in the console, but right here, we use a 45 connector for everything, and then for the 5 main harnesses. So I just did one, the easy one.
Wow.
And you can see here the side that is connected to the console is the two connectors, and the main switch harness, this connector that goes to the electrical cabinet that has 45 pins. And I have to say, SolidWorks Electrical really helped us with this, because after you put them, you know what? Let me show you straight in the SolidWorks Electrical. So
Okay,
you can see.
sure.
So it's okay. So here, this is an entire truck. I don't know, you can see the menu is, we create this is like a template for one kind of ambulance that we're working on. It's called F series. And we create a template with every single drawing that will be needed for like a basic drawings, that schematics that are needed in every truck for this kind of ambulance. So this package that you see is very big. Is a lot of drawings, and
Oh,
but
wow.
every,
Yeah, it is.
you know, for the sirens you need one, for the front flashing lights you need another one, for the air conditioned you need another one, and on and on and on. Sometimes you see an ambulance passing through, and then you just see a few lights flashing, and you hear the siren, and you don't even know there could be like a 300 and something, like 50 tons that you can set in your siren. And you just hear some tons, always you pretty much hear the same thing. So it's kind of neat to know this. So so this is my template that we're trying to implement. So anytime we get a new truck, I'm gonna just run this. I created like a new. If I create new, this is what they are gonna start with. So it's a lot of work saved for a new job. So in case that we need, the customer don't want 6 lights inside the truck, but he wants 10 lights. So we just have to come here and look for the down lights and delete the, right here. Delete this schematic and then replace it. We create, I don't think I can open it here because this is not the base, the SolidWorks Electrical, but we have in our library has created macros. So all these schematics, each one of this is being created in a library that is the macro library. So each one we can go and access and replace or get it, just going to the main book and say insert project macro, and then here we will have the let me see, you can see here some of the ones that we have. So like the 10 lights, see this one, this light look cool. So this is an air horn. So if I want to put it in, I just have to find it. And that also is very easy to find. If you don't know the number of the drawing or all the name specific, you can just go in the filters, description, type what are you looking for, and the software will find it for you and give you the choices. So it's very easy to add to my main job. So I'm saving time. Used to be a little bit more work to get something in my book to get all this truck ready to go.
Wow, this is like incredibly sophisticated. I honestly, I didn't expect to see this level of sophistication, because I think Sean said that you guys got started with SolidWorks Electrical not too long ago, right?
Yeah, I've been really like a year ago. So
a year ago. Wow. Okay. Yeah. I mean, that's incredible. I mean, you have these templates for each of your vehicles, and then, for any adjustments you need to make, you have like these macros. I don't know much about SolidWorks Electrical, so I'm learning a lot today as well. But that's pretty unbelievable. You guys have become very sophisticated with it very, very quickly. Is that pretty typical, you think, that companies can get to this level of sophistication on this tool like that quickly?
Well, you have to invest time and learn, because the software is a big machine that gives you so many tools. Yeah. So sometimes it's intimidating, because even just to create a symbol, we are seeing this symbol right here, but what the machine see, I don't know. Let me see if the machine will let me up. This is what the machine see.
Okay.
It's totally different, like wow, what is all those signs and links and which one belong to what? So in order for me to get the description or location, I have to has the link here. So take time to learn, but after nobody has to go to that symbol. You learn how to set the symbol right. You just drop it there, and then when you drop the symbol that you need, the software will open this window, and here you pretty much put anything you need. All you're gonna need for any kind of report in the future is here. So the location, what is gonna be, the name, how you're gonna call this, what is specific, because like you see here, I have 2 USBs. So, here you can be more, describe better anything you want for the customer. So another cool thing about macros, and now I just remember with this one, say U1, this is going to be used all the time. Like you don't know how many USBs your customer wants. So you just can drop it in the macros, say USB. I'm gonna call this Luz Elena USB, just to put it a name. So I just, I'm creating a macro. And then now, I lost it here. Just 1 second. Again, okay, sorry. So I have it here. And from now on, I can add as much as UBs already with the connector, with manufacturing information ready. And the USB also will have the main information that I already put there. So this is very neat because it's super easy. You can add whatever number of parts you want, and you're saving time. You don't have to go and put the characteristics on the, maybe change the name, and that's it.
Each episode that we've featured so far has uniquely highlighted different ways of both geometry making and production. And our last featured episode of SOLIDWORKS Live Design from 2023, so far, that is really no different. So Andrew Lowe appeared on SOLIDWORKS Live Design recently, producing one of the most viewed episodes of the year as he showed off particular considerations and methods to adding fillets and blends to his parts and assemblies. So the designs that Andrew gave us a peek into were produced in his capacity as design director at industrial design firm Cortex Design. Let's check out one of the most viewed snippets of this episode, which was hosted, by the way, by Steve Fick.
Likewise, this is a product for detecting certain kinds of infection after certain kinds of surgery when the patient is still recovering at the hospital. And because this device is being worn on them and the patient's in bed, we wanted to have a very smooth, sculpted, almost pebble-like appearance. So that way the device was very soft. If you were sleeping and you accidentally rolled over and it was underneath you, we didn't want that to have hard edges. And so this was an example where everything was of the the G3 connection, and we had that very smooth, sculpted, almost like a pebble that you find on the beach that's been worn smooth by the nature of the tides over time.
Got it. So maybe you're going to take us here next, but how do you go about, so we looked at kind of that 2D profile example, but how do you go about achieving this in like 3 dimensions where, like I've got kind of that, the teddy bear example or a corner that's coming together?
Oh, well, I'm glad that you asked, Steve, because I've actually got a baked out example that we can run through. So I'll jump to the end here. Actually, no, we'll jump into SOLIDWORKS. I think it'll be a little bit faster. And let's bring up the completed model. And this is something that's more than just a corner. I do want to have a little bit more geometry, a little bit more nuance to the shape.
Yeah, while you're bringing that up, if you guys have questions about this, by all means, add them to the chat. Andrew, I think you're getting a couple suggestions for maybe a couple YouTube videos about modeling a coffee mug handle and whatnot.
Make a video on the handle profile of a coffee mug. Yeah, that's an interesting example of, want to have that handle blend out nicely, for that slip cast ceramic. We're just going to hide the cameras. Cool. And I think we're going to turn off perspective because it's going to jump around. So this was just a little imaginary device that I had whipped up for a presentation this year at 3D Experience World. It could be anything, but one of the hallmarks of this design was that we were going to incorporate a rounded LCD display. Rather than having something square, perhaps the particular functionality and user interface that was determined, it made sense to have it round for whatever reason. But that's the nice thing when you're just imagining shapes, is you don't really have to justify the function and justify what it's actually designed to do.
Sure.
But this example brings up a couple interesting tidbits, and that also plays into the use of the style spline and now in later versions of SolidWorks, the G3 torsion continuity relation. So I have a very simple layout sketch, and I have a slot entity, and then I have a call out for the raised portion where I'm going to have my display. I don't want to have it on the same flat face as the model. I would like to elevate the display from a styles perspective, so that way it's a little bit more prominent, a little bit clearer to the user. But if we were to look at our curvature of a slot, once again, I have this very abrupt transition, and I want to smooth that out. And so I need to create a bit of a transition where I have a portion here that's being replicated by a style spline rather than it being an arc. And so in the same way that I had used the fillet tool at the sketch level to call out a larger transition, here I have some lines being used to split out a little area that I'll replace with my G3 connection. And I'm just using some angles here to fully constrain these lines.
Okay.
So I have my splits. So I'm just calling that this is the little area that I need to create my G3 transition. And I'm jumping in here. And there's a couple ways I can go about doing this. I can manually eyeball it here. So I can kind of, drag this to where it's almost at the point that my style spline works. But if we were to start from scratch, what I'd like to do for this perfect transition is style spline. And I know I need degree 6 because I have my 3 control segments each direction. So I could even create this and go up to 6. I'm going to set the first bits to be equal. And in the second portion, I'm also going to set them to be equal. And with this example, I can set them to be collinear. And I'll need to just, before I do this, I find it prudent to kind of drag the shape to almost where you want it to be. There's a tendency to not over constrain itself. And then I can set the torsion continuity. And because I had set all of those segments to be equal to each other, it's now fully constrained. So I don't have to worry about those points moving in space. I have a fully black style spline.
Yeah.
Question in chat: how did I decide upon the angles? Experience. Sometimes you want a little bit more. I just kind of play around with the angles, and that's why I like having this driven parametrically, so I can turn on my style spline and have that very gradual transition.
Got it.
So I now have that smooth transition that I can use to create some model geometry. And this is going to disagree with me because I deleted, in the sake of the example. So we'll just reload so I don't have the dangling sketch. And we'll run back up in the tree and turn off that camera. So running back, and I'll turn on model edges so it's a little bit easier to see. I'm starting with a solid, right? Rather than starting with surfaces, I get more features all at once.
Mm-hmm.
And the reason that I started with a solid is I wanted to do a cutback. So there's going in industrial design, we kind of call this a pillow top or a crown top, but you'll see it in a lot of consumer electronics, medical devices, et cetera, et cetera. It's that hallmark shape on the top of a laptop where you have a very flat shape and then it looks like it tapers off on the edges.
Oh, sure. Yeah.
And in order to do that, I need to get some new model edges. And I'm accomplishing that with a cut. And actually, I'm accomplishing that with a cut with a thin feature. So I'm just using this to create some new edges.
Yep.
When you're surface modeling, you're more worried about the edges and the faces. Solid modeling, you care about the overall shape. But solid modeling is a great way of getting you faces, getting you edges to be able to work with the geometry. One thing I do want to call out, though, is that depending on how, so actually this is converted, is the way that SOLIDWORKS is handling offsets. So this is an example where I've offset everything, and I'm showing the curvature cone. So I have this 12 millimeter offset dimension. And unfortunately, it doesn't handle the offset of splines the best. You can actually see that there's this weird kind of like taper in the curvature.
Sure.
And so when you're doing this kind of final, and actually in an example, the larger the radius, the tighter this actually gets. So if I set this to say 18, you can see that issue is exaggerating itself. It's starting to get very sharp in this corner. And you can almost see that with shells. So using the shell feature with curvature continuous geometry, those radii get super tight. We just do a quick example of that to help demonstrate this phenomenon. So if I had a block here and I radius the corner, maybe 25 to really show this off, I'm going to go curvature continuous. And then let's shell this part with a 10 millimeter wall. I'm going to pick these faces because we want them to go away. My corner starts getting very, very sharp, and this exaggerates the bigger the shell is and the bigger the offset. So in this, it's almost perfectly sharp there, and the shell tools actually split this into two faces. It's just the way that SOLIDWORKS handles the offsets. But you can work around. It's a little bit more work, but it just means in this sketch example, what I've done is created my own. I just used the offset tool to get me the arc and the line because that's mathematically offsets perfectly. And then I've created a new style spline here. And if I wanted to link these parametrically a little bit more, I could actually pick the control segments one by one. So I could pick this one and I could pick this one and I could go along and I could make them all parallel to each other.
All right, everyone. Thank you to our production team and all of our live design hosts and guests so far this year. To keep up with SOLIDWORKS live design throughout the year, visit SOLIDWORKS on YouTube, subscribe to the channel, and sign up for notifications. Next up on our live calendar, for me at least, well, the most wonderful time of the year is here. It's SOLIDWORKS launch. What's new 2024? The season is upon us. So our team's been putting together tons of demos to help you study up and level up with SOLIDWORKS 2024. And we'll be back on SOLIDWORKS Live very soon at a special date and time, so mark this down. It is Wednesday, September 27th at 11 a.m. Eastern. So you can visit YouTube today to set up a notification for this episode where you will assuredly receive jam-packed looks at the best of what's new in parts, assemblies, drawings, and much, much more. Thank you to everyone out there. Thank you to all of you on YouTube, LinkedIn, and everywhere else that you are tuning in. Until next time, take care.